Hey guys, it's Mrs. Bryant. Welcome back to Flipped Video. Today we are going to continue talking about radicals, but now we are going to include some exponents. So I need you to get out the note pages I gave you in class today, as well as the foldables. And the foldables were green, and make sure you have all of that ready. And when you are ready, you can hit play and we will continue the lesson. All right, so fill in the values for the powers of 4 below. This is just a review of exponents. So 4 times 4 times 4 is 64. 4 squared we know is 16, and 4 to the first power is 4, and 4, remember, anything raised to 0 is 1. So what do you see and what do you notice? Every time an exponent goes down 1, we are dividing by 4. Okay, more power patterns. Fill in the value below. This is a brand new, so just take your best guess. If 4 to the 1 equals 4 and 4 to the 0 equals 1, how did we get from 4 to 1? And that's going to be divided by 4. So 4 to the half, what do we think it's going to equal? It's going to be 2. And do you think this will work? Will this pattern work with other bases? Well, we're going to find out. Here is a review of how to do exponents in a calculator. Remember, you're going to hit this caret, and that'll make it into an exponent. So on your notes, here we go. It says, fill in the value below. Try your best to use your calculator to check your answer. So how did we get from 9 to 1? And it's going to be divided by 9. So what do you think 9 raised to a half is going to be? You should have said 3. Okay. It's a geometric sequence, right? So divide by 3. Divide by 3. Overall, you're going to get divided by 9. See if you can use the same pattern for these other powers, then check your results on the graphing calculator. So we did these first two. 16 to the 1 raised to the first power is 16. 16 to the 0 is 1. How do we get from 16 to 1? Divided by 16. So divide by 4, divide by 4. All right. 25 to the first power is 25. We know that 25 to 0 is 1. So what do we think is going to go here? You should have said 5. 36 to the first power is 36. 36 to the 0 power is 1. What do you think is going to go here? And the answer is 6. So we know that the square root of 4 equals 2. We also know that 4 raised to the 1/2 equals 2. So that means the square root of 4 equals 4 raised to the 1/2. This is called the transitive property. And it means when two expressions equal the same thing, then those two expressions are equivalent and can be used interchangeably. Following the same thought process, we know that the square root of 9 equals 3. We also know that 9 raised to the 1/2 equals 3. So we know that the square root of 9 equals the same thing as 9 raised to the 1/2. So now we're going to connect fractions to radicals. So we know that the square root of 9 can also be written as, this is called an index. And it just tells you what you're taking, like, so this is a square root, but you could also see cubed root and so on. If there's no number here, we automatically assume it's squared root. So square root of 9 can also be written as the square root of 3 squared. So based on the exponent rules, 3 squared, or a square root of 3 squared equals 3 squared to the 1/2, which equals 3 to the 1, which equals 3. And that just means you are multiplying these fractions. 2 times 1 is 2, and 1 times 2 is 2, so that's 2 divided by 2, so that's where you get the 3 over 1. So, in other words, this is important. The square root of a number x can be written as x to the half power. You need to know this. This is super important. So let's take that a step further. Remember, the exponent rules tell us that a raised to the m, which is then raised to n, you are multiplying those exponents. So based on that rule, how could we simplify 9 cubed raised to the 1/2? And you're just multiplying 3 times 1 is 3, 2 times 1, because that becomes a fraction, is 2. So 9 raised to 3/2 equals the square root. This 2 becomes the square root. And then this becomes your exponent. So the square root of 9 raised to the 3rd. When you do the math, that means the square root of 729 equals 27. Or you can write it a different way. 9 raised to the 3/2 equals the square root of 9 to the exponent of 3, because that 2 is still your square root, and your 3 becomes your exponent. And that means square root of 9 would be 3 raised to the 3rd equals 27. So let's try one together. Try 4/9 raised to the 1/2. So you start with the 4, make that a fraction. So 9 times 1 is 9, 1 times 2 is 2. Okay, so to continue, this 2 became your square root. This 4 is still your base, raised to the 9th, because that is your exponent. So doing 4 raised to the 9th on the calculator, you get 262,144. And if you take the square root of that, you get 512. And I did that on the calculator, so there's no work to be shown. Another way to write it is 4 raised to the 9/2. This 2 became your square root. Your base stays 4, but it is now raised to the 9th power because your 9 becomes your exponent. So square root of 4 equals 2 raised to the 9th power. And if you do that in the calculator, you will get 512. So let's try another one. Your base is still 3. 1 times 5 is 5 over 2, because this becomes a fraction of 5 over 1. We now get this 2 becomes your square root, and we have 3 raised to the 5th power. If you do that in the calculator, you get the square root of 243. And once you simplify that, you get 9 square root of 3. And remember, to simplify, you find your prime factorization. Now, why do you think there's only given one option to solve this problem? And why do you do the exponents first? The answer is there's only one method shown here because it is not a perfect square. 3 is not a perfect square. That's why there's only one option. So let's watch this video.
In this video, we're going to talk about radical notation and simplifying down radicals. So a radical, again, kind of the most basic example probably everybody is used to seeing, is a square root. So suppose I'm trying to find the square root of 25. Again, they don't write it, but it's understood there's a little index here of 2. And whatever this number up here is, it basically means you need a number multiplied by itself that many times, in this case 2 times, so that we get the number 25 back. And I need the exact same number inside of here. And notice that 5 times 5 equals 25, and that is going to be the solution to this problem. It says the square root of 25 is 5. Now, notice also that negative 5 times negative 5 would give you positive 25, but the way that we just define square roots, or any even-powered root, is we only want to use the positive solution. So even though negative 5 times negative 5 is 25, we would never say that the square root of 25 is negative 5. We just use that positive version. So another example here of this idea. Suppose we have the cube root of 8. Okay, so in this case it says I need a number multiplied by itself 3 times so that I get positive 8. Well, again, notice that 2 times 2 times 2 is positive 8, so we say that the cube root of 8 equals 2. If we had the cube root of negative 8, what would the solution to that be? Well, in this case, we can't have a negative number as a solution because I need the number that I get out to be negative, and if I multiply a number by itself 3 times, the only one that's going to give me a negative out is going to be if that number is negative. And notice negative 2 times negative 2 times negative 2 does give me a negative 8. So the cube root of negative 8 is negative 2.
Okay, go to your green foldable. It says use what you have learned to fill out the graphic organizer in your interactive notebook. And it says use the following letters to help you fill out your organizer. We know that your denominator becomes your index. And the exponent is going to be your numerator. So make sure you have that written on your foldable. Now, it says practice simplifying. These are the 4 examples that you cut out of your foldable, and we will do these in class tomorrow. So what I need you to do tonight to make sure that, to let me know that you watch the video, I need you to follow the Google link in the description and answer the question on the Google form and submit it to me with your full first and last name. If you have any questions, like always, make sure you put them in the comment section so I can get alerted and answer your questions. That should be it, and I'll see you in class tomorrow. Bye.